Just give me also a few words about yourself. So what
Yeah,
is your
please,
area of interest?
this is a safe place. We want it to be a safe place. I'm just resetting my screen so you might see something is suddenly changing and so on, but everything is working out all right. So this is a safe place. We want it that way. We want to build a community also. So over a period of time, we get to know each other. So please don't be shy and don't worry about introducing yourself. Be the person you are. Go ahead, please. Introduce yourself with few words like what Gaushali is telling. Okay, go ahead.
If you have any difficulty, you can put it in chat. I can read it for you. So we have one more participant, Mr. Nazri. So Nazri, where are you from and what is your current position, Nazri?
Hi, sir.
Yeah,
Welcome.
welcome,
My name
Nazri.
is.
Welcome.
Hello, sir.
Yes.
Good evening. Yes. Hello, sir. Good evening, sir.
Good evening.
Welcome, Nazri. Good
My
evening.
name is Sajja.
Go ahead, please.
Okay. So I completed MBA in Finance and HR.
HR.
Okay.
MBA in Finance and HR.
Oh, MBA Finance and HR. Go ahead. Oh, okay. So you have an interest in
Yes.
time series, especially. Okay, cool.
Yes.
Wonderful.
Actually, after completing MBA,
Go ahead.
hello.
Yes, I'm hearing you.
Yes, we can
Perfectly
hear you,
hearing you.
Nazri. You can go ahead. Yes, tell me. So you completed your MBA
Yes.
and what you are doing currently? Yes.
Actually, I'm 2019 passed out student.
Mm-hmm.
Okay.
In between, I had 2 years gap because of my marriage and all. So now I'm
Mm-hmm.
looking forward to my career, to start my career.
Super. So what is your
Okay.
interest in data science? You are a finance, MBA, and HR. So what's your interest in data science?
Yes.
Are you planning to do something using analytics in your job in finance or HR? I guess so. Okay.
Yes.
Or if
Yes.
there is anything
Yes.
special you can add. Okay.
No. I'm actually I'm looking like
Yeah, I
data
believe that.
analytics.
Sounds good. Sounds good. Welcome, Ms. Nazri.
Nazri,
Go ahead.
definitely this sessions will help you. The time series forecastings and all, definitely it will help you to your interest. And we have one more participant, Mr. Ganesh. So kindly introduce yourself, Ganesh. Where are you joining from and what is your interest in data science?
All right. Okay.
Yes, and we have one
Ganesh
more
has.
participant like a webinar assistant, registrant.
Yes.
Okay, so webinar
Mr.
registrant, can you please, can you please
Yes.
unmute yourself and give some inputs about your.
Yeah. Okay. That's fine. I think people are sometimes
Yes,
like this.
participant, here it is an open.
No, it's okay.
As the sir has told, it is an open community. You can ask all your doubts here. Here we give for each and every students we give special attention to you, and whatever you have difficulties in choosing your career, you can ask all the doubts. So here we have a teams to guide you in the data science field to get into a job. So that's how. And right now I'll pass it on to Dr. Nita Samamuti to take over this session. Thank you, sir.
Right. Thank you very much, Gaushali. We try to make this, place of attendance, learning, community, a very comfortable place for everybody. So we encourage you to talk. We encourage you to introduce yourself. Be the real person you are. Don't hesitate to interact. Okay. Asking your question is the reason why you are here. And my promise to you is that, I will try to compress this knowledge to make sure that, and that's always my joy, when I teach, that's my purpose, that give the minimal information to maximize the structure of thinking, how to observe, analyze, interpret, and create, articulate intelligence out of the data analysis. So that's my interest usually. So today is the last day, but it's a very important, very powerful methodology called forecasting. And even though I say here R and Python, in this session, because the commitment is Introduction to Statistics with R, I will only be talking about R, okay, in this session. So first and foremost, you want to understand what is meant by a series, and then you will think about, because we are also bringing, the programmatic connection to our work, which is in this case R. We have to understand what is meant by a series and then connect it to the time. Okay, how it is defined as a series and connected to the time. So I will go back and forth between the theory, between the time series analysis of statistical analysis and the R, how it constructs the series, handles the series, utilizes the series as time series, and provides solutions for us. Okay, and very simply, a series is a vector. Okay, is a sequence of numbers or characters. It could be characters also, but for all practical purposes, we are going to talk about only the analysis of numbers. That is, a series is a vector of sequence. Okay, sequence of items, sequence of numbers. It's a list, so you can recall a specific element of a series, and in R you define like this. I'm just introducing you, warming up about series. The label for a series is an index. An index is useful if it's uniquely defining the rows, so we know exactly which row it refers to. Okay, if a vector is from column wise, column wise at 1, 2, 3, 4, 5. I hope you are seeing me, right? 1, 2, 3, 4, 5. Then the rows are identified by the index. The index is not fully visible in R when we define series. A data frame is this is a very interesting statement. I'm kind of giving you a lot of little things here. A data frame is a column bind of multiple columns of series. This is a fascinating advantage because it combines different data types in a rows versus column structure, which is common in data science. Okay, that's about a little bit about what is meant by series. But the main thing I want to talk to you is about time series. And given a time series, that means the index is time, not a number, a position. It's a time. So given a time series, imagine what you would be wondering. Okay, obviously you want to visualize that, right? That's one thing you want to do. And then what do you want to do? You want to see, is there any, because the time is involved, time is always provides you opportunities for repetitive process and trends going up, going down, right? So you want to think about, articulate trend or repetitive patterns. Okay, so we call trend or seasonality. Repetitive patterns could be weekly, monthly, even hourly, right? But the thing is, any repetitive patterns we will call it as, broadly speaking, seasonality. We won't talk about only seasonality means the 4 seasons in a year. Okay, so you really want to do articulate what's the trend in that. Of course, estimate trend and articulate it, and then estimate repetitive patterns and articulate, which is called broadly seasonality. You also want to smooth the series. Why do you want to do that? Because you can focus on trend and seasonality. Okay, it's not easy to pull out the trend and seasonality unless you smooth the series. Okay, to remove the randomness in the series. And then you also sometimes the seasonality is not good enough. So there is seasonality in the short term. There is a big cycle that happens multiple seasons, and then it picks up the huge lift and then huge throw. Okay, down. And that is called cycle. So cycles are multiple patterns coming together, multiple seasons coming together, and then cycles are coming in. Okay, so business cycles are common. Every 5 to 10 years, you see some huge, around 5 years, huge, cycles going up and down. Okay, that for some reason it happens. Now, we also fascinating is, in order to do all these things, we also want to separate out or decompose. Sometimes we call it as a decompose the trend, seasonality, cycles, and the remaining residual. Okay, so that's what we do, what's called as decomposition. And then that means it can be an additive decomposition, that is seasonality, trend, residuals. So when we say seasonal, we include cycles in that. Okay, trend and cycles. We call it as trend and cycles and seasonality, okay? And then residuals. It could be multiplicative, it could be additive. And of course, finally, you want to do, can we do some advanced regression type modeling in time series? That's what is called the ARIMA X, okay? And I didn't talk to you, or I didn't tell you what is ARIMA. I'll talk about that. ARIMA X, or sometimes we also extend it to S ARIMA X, or seasonally adjusted ARIMA X, okay? Algorithms for time series forecasting. So this is what you should be thinking about when we talk about a time series. A time series is a series of observations with time index. What is that one more time? Because a couple of you came a little bit later. I'll say we want to think about visualization, okay? And visualization, of course, means with respect to this, with respect to this, with respect to this, everything, right? It's not just plotting the scatter plot of the series. Of course, that is one of them, but it's not. There is also the decomposition and visualize, Arimax models, visualize. These are the advanced models you can think of. And then if you put this in the vector notation, that is multiple time series data, then you are talking about vector ARMA, vector SARMA, and so on. Okay. So think about these 6 things you want to do. When we think about time series, that's what you're thinking about. Okay. And in terms of words, there are different methods that are coming in. So we will talk about auto regression. That means the time period today depends on k previous time periods. It is true, right? We say baggage, right? In common formula, we say he has a baggage. That means it has affecting from the past, right? So that's what is baggage. Moving average refers to the error terms are correlated in the previous error term. So this is a structure correlation. Autoregression refers to structure correlation. Moving average refers to error correlation to the past. Both the cases past. And then sometimes you may want to combine these things, autoregressive, moving average together. Okay, that's the most that's a very sophisticated model that you combine both of them. Furthermore, this is applicable only when the data is stationary. That means it doesn't have trends. Okay, that means trends means it has the changing mean. Okay, if it is a changing mean, then the ARMA models have problems. So what we call as a different set, also called the integrated. That's what autoregressive integrated moving average. That means we apply a technique called different thing to bring back series without changing mean. That means without trends, without patterns. Okay, so when we remove the trends and patterns, deseasonalize it, detrend it, then you can apply ARMA model. So that is called ARIMA. Okay, and deseasonalized detrending is usually done by different things. We will talk about that. Seasonal, and then there is also called ARIMA. Okay, so seasonal autoregressive integrated moving average, and so on with exogenous variable, which means covariate. Okay, that is what ARIMAX. And then, of course, when you do this into vector, multiple time series, then we call it as a vector autoregression, vector ARMA, that is vector ARMA, and then vector autoregression with the covariate, ARMA with the covariate X, also called exogenous regressors. And there is also called smoothing methods. In addition to that smoothing methods, you remember I talked to you smoothing methods. Here is the smoothing methods, right? So, and those smoothing methods are also talked about in general. So I'm going to kind of give you the overview and give you a case study also. And in between, I'll talk about many terminologies and then with examples and visualization. So let me just go. Here is an example, right? These are some 4 exchanges, DAX exchange, that German, and FTSE refers to financial time series, okay? Financial data. So these are all you can see. It's a point in time, and then there is their indices. Okay, that is all 4 different series are plotted here. And then here, if you look at it, the time with respect to number of airline passengers, and you can see, it's very interesting. This is one thing that it is trending going up. The trend is going up, right? But here you can see the trend is also going up. But interestingly, the variation is also going up. That means it is more and more increasing. The variation is more and more increasing. On top of it, you are seeing some patterns here. It peaks here, peaks here, peaks here, peaks here. Approximately every year it is peaking, right? Not approximately. It is peaking every year during sometime around September, sometime around, summer. I think it is summer, okay, end of summer, very close to end of summer. You can see that, and it is always common, right? That is called the seasonality, okay? So that's an example. So then the question you have is, oh, okay, wait, I have a series, how am I going to handle that? Because I need to connect them with the time. I have to deconnect it, and then, make changes to the time and all those things, right? So it is a very easy way. The package, forecast package, as well as, the, what is called the Lubridate package, helps us to do the processing of time series data. So for any input series data, you can define a time scale where it starts. In the start, it says, for a given data, it starts in 1959 second quarter, because based on the frequency, it figures out it is a quarter, this is a monthly, and then, but the starting point is second quarter. That's what it says. So something like this will simple command will help you to align the data in the right way for you. Align the input data, in this case, align the series of data with respect to your time. Now you can plot it. You can work with other packages that we have. Okay. So that is what why don't we do a little bit of fun activity here? Okay, there is so much to do. Okay, but no worries. So let us say I have an input data. Let me see. So I can generate an input data. I call it as I have to have input data to define a series, right? Time series. Remember that. Huh? So first I'm generating an input data, or I'm just simulating a data, and let's say 50, 20. That means I'm generating some data. Don't worry about it. Okay. Now I take that as input data, right? So for example, if I do this, if I just say input data, this is what the data is. But there is no time aspect, right? But that's where the TS package part of the Lubridate, right? So I would say Lubridate. Okay, I have to use Lubridate TS. No, stats TS. Okay. Yes, that's stat asset. But nonetheless, it is automatically loaded, so I can use it for this to define the time. Along with that, let me do that. That's what we are doing here. So I have some series, right? Now I'm connecting it to the time index. Okay. So now you can see that it is connected the same series. It starts with the quarter 2. I'm not sure whether you are able to see this very well. Maybe I can add a little bit more, bigger font size perhaps. Okay, so you can see that I gave the input data, something like 100 observations, not like some 100 observations, and then I said, I need to index it as time based index. So that means start 1959, with the starting time, second quarter. That's what it is. Okay, second quarter, and then it index it. It's a beautiful time series. If I plot it here, oh, I didn't store it. Did I store it? No. But I can just actually, very interesting. I can do this. The beauty of R is that it's a functional language. I get excited on that particular part. Few things about R. So one of them is it's a functional language. So you can construct function of a function of a function. So it's really, instead of putting input data, I can as well put. I take the input data, frequent, the input data I haven't defined, right? So now I can define I have already defined it, but I can actually define it here also inside. That's what I'm saying. So it's a function of a function, function of a function, and so on. In one function, I can do wonders. That's my main point. So I said it is a normal. I want 100 observation, not here. 100 observation, and then I want a mean of 50, standard deviation of 20, and then I want to time series it with the index with the frequency port. That means quarterly starting this, and then I plot it, right? So I plot. So you can see the function of a function of a function, right? Let's see that. So here is the plot of that one. So the beauty of this is, okay, it's began this. Beauty of this is that it is, time sequences here. If you want, you can also put every time, but here it's done, right? It's a beautiful time series. You can see an exception, but it just so happens. So the other thing is, when you look at visually the data, you really want to make sure that some exceptions are handled properly. So I am quickly going into what is the method to follow in time series analysis, especially if you are going to do the ARIMA model. Okay, so plot the data, identify unusual observations, understand patterns, check and do the box-Cox transformation to stabilize variance. So I told you one of the airline passengers, slowly it is up and down, up and down, up and down, increasing, but then the variance keeps on increasing more and more as we go into the future, right? So in such cases, log transformations can help, and that is also called the multiplicative model. Okay, remember this word: additive model, additive series or additive time series models versus multiplicative time series model. The way to handle multiplicative time series model is to use log transformation. So that, in addition to log, you have other transformations you can use. That's what is called the box-Cox family of transformations. But don't worry about it. Mostly these two is good enough. Additive, multiplicative. Additive is as it is. Multiplicative is log transformation. Now, once you do that, you can do the automated ARIMA. There is an available automated ARIMA is available. Do we detrend? A great question. I'll come to that. Okay. 1 second. Okay, there is only one question. Do we detrend doing box-Cox? Okay, the detrend is not happening at that time. You do the box-Cox first to I'm trying to use the word word called D, but it is to reduce the D-variance, if I can use it. Reduce the variance, so that you can start doing other things like detrending, de-seasonalizing. Okay, the first should be your variance stabilization. Okay, good. Thank you very much on that one. Good question. So that's why it is here. First you see plot the data, identify unusual observation, understand patterns. So you already know there is a seasonality going on, trending is going on when you visualize the data. That's the beauty of visualization. The human knowledge is now coming into the process. Okay. Now, once you do this, whether you want to go, you want to do it yourself, do the best model yourself, or you can do automated model. By that, what I mean is, it will generate tons of models, and then using AIC, Akaike information criterion. There is some other session I have to do about what is this Akaike information criterion, why it matters, and what are the other additional goodness of fit measures. So these are considered as the overall model selection measure. Okay, Akaike information criteria, you can use it to select the best model here. Okay, and then you still have to do the residual analysis, because we don't know, is this good enough, right? The residual still may show some unusual things, even though your AIC comes out to be nice, the lowest. Okay, depending upon the sign, lowest or highest, you have to remember all those things. Or you can do, manually as a hardcore, manually done work. Okay, if you think that human intelligence matters a lot, in your work, that's okay. You can do that. Then, but nonetheless, the auto ARIMA will do your different thing. Okay, this is where the detrending, deseasonality is going up. So use differencing to achieve stationarity. That means stationarity refers to there is no patterns of trend or seasonality into the data. Okay, you need to remove all those things if you want to do the what is called the ARIMA models. I mean, ARMA models, because ARIMA, the I is the different thing. Okay, so so once you do that different thing, then the kind of only there is something looks like random variation. It is still random, not random. It looks like that for us, but you will see by looking at the autocorrelation function, partial autocorrelation function, you will realize that the ARMA models. I'm going to talk to you about what is this P and Q are. The P and Q refers to the ARMA model. The autoregressive, the autoregressive maximum and autoregressive lag parameter is P. That means number of lags it needs on the autoregression side, and then Q refers to that many number of lags you need on the side of the errors. Okay, the moving average errors of the errors. This is autoregression of the the time series values. And then once you determine this P and Q and also D, because one difference may not be enough. Usually by second difference, all your D trends, it D seasonalizes. Okay, so usually 1 or 2, 0 or 1 or 2 here, and here it could be again. It doesn't go too big number. Usually 1, 2, 3. That's all. It's not. Most of the problems are okay, but nonetheless, you need to do multiple iterations of all these things to figure out what is the P, Q, and D. Once you know that, you do the model estimation and then figure out your best model using AIC, that is Akaike Information Criterion. Again, you even though you think that you have done the best, you still have to do the residual analysis as a stopping rule, because the residual should really look like normal distribution. Okay, so you can see the QQ plot is coming here also. Okay, and then once you are satisfied, you do the forecasting using the model you built here or here. This is the strategy map. Okay, for the time series analysis. Of course, here I said ARIMA. Okay, you can also do the SARIMA, BARMA, all those things. But everything it is pretty much the same pattern. Okay. So I wanted to just get that attention for you, so that you think all through. You keep this kind of mindset when I explain few things here for you. Okay. So I mentioned that. Okay, I kind of already said this. What is a stationary time series? The stationary time series is the one which doesn't have trend, local trend or long-term trend, no seasonality and so on. Okay, that is achieved by different things. Then I said you have to decompose it, okay, and detrend it, deseasonalize in a series. What is meant by autocorrelation? All those things we kind of, I'm kind of addressing it. Let me continue to go on this direction, okay. Now here is that the passenger data. So you do plot the actual values, or the square black ones are the actual values, and then the connecting lines, are the actual values, and then the green ones are the predicted values after you finish the model. And then you always do validation. You remember that in training, testing, and then validation, all those things. The validations are done, for a small period, usually, right, in the future, into the future, right. So build the model up to this, and then you validate it for another 1 year, right? These are the round holes are the validated points. It's pretty much fitting very well. Looks like a great model, right? And then once you believe in this, you forecast it, and for this is the actual back testing. Remember that this is called the back testing. You have the data, but you didn't use it to build the model, but you use the model to predict them, and they fit in very well. Looks pretty good. And now you believe in this, the errors will actually look nice, because you can see that the prediction is very close to the original black series. So then you believe in this, and you can use the model, and you use this model to predict the next 2 years, or maybe 1.5 years here, very close to 1.5 years. Okay. Now you can see that this is this is a multiplicatory model. Why is that? Because the variance is increasing here, right? Small variance, smaller, medium variance, large variance. Okay. And yet larger variance. So you have to use log transformation to the data before log transformation. Your strategy is what? First you do the log transformation, and you do the different thing, so that you can remove the trend, right? And then we do the model, ARIMA model, okay? That's what your strategy is. Is everybody good? You understood the strategy very well quickly, right? Any question here, statement here that I can address? Any comments? Okay. So I want to take this moment to let others, once again, those who joined a little later, to introduce themselves. Mr. Karthik, Mr. Ravi, Ravi Teja, Mr. Karthik, Sumati, Ms. Sumati, can you please, of course, respectfully, Mr. Webinar registrant, can you please say a few words about yourself? Zulfi is also included. We call it as Zulfi or Zulfi, please, forgive me. Okay. You can. That's the reason why you can introduce. Go ahead, please. Few words about yourself. Ashish, Agish. Say a few words,
Yes,
please.
hello,
We know about Brian. Go ahead. Sorry.
Yeah, so I am Hish. I am connecting from Pune. I work as a supply chain consultant at an IT company. So I specialize mostly in supply chain analytics.
Excellent, sir. Welcome. We know Brian, okay, from Calgary. Welcome, Brian. Go ahead. Next is, please say a few words quickly. Karthik, Chris, Mubin. Go ahead, Ravi, please. Ms. Sumati.
Yeah, I'm from Chennai. This is Karthik here. So I actually, wanted to learn into data science and other related areas. So This is just my exploratory analysis kind of thing.
Yeah, sure. It's a science to be in right now. Data science, machine learning, AI. Best place. Fun place also. I think it's an investigative work. I love it. Chris, Chari, please say a few words. Welcome, Mr. Karthik. Moving next.
Yeah, hi, this is Movin here. I'm connecting from Bangalore. Yeah, I'm working as an HR executive now.
Super. Very good. Excellent. Welcome. So what's your interest in data science?
Yeah, actually, I have completed with my diploma in computer science. So I have to enter in the IT sector. So I'm looking to do my data science course because I joined the webinar.
Oh, okay. So you want to move into a data science area? Is that, or you want to use data science for HR? I can't hear you. Okay. All right. Move on. Chris, Mr. Chris, say a few words, please. We love to hear you. This is a free session we give you. We spend our time. At least we would love to hear you, who you are, where you're joining, what's your interest, and so on. And we are trying to build a community too. Go ahead, please.
This is not Mr. This is Miss.
Oh, I know you. Go ahead, Krishna.
I know you know me. That's why I was like, should I talk? I just saw your name.
Yeah, welcome, Krishna.
Just
Krishna is, I work with her. She's in San Francisco. I will introduce San Francisco. She works with me also as a TA or instructor in Northwestern University. So welcome, Krishna. It's great to see you. Ravi Teja, Mr. Ravi Teja. Come on, guys. Okay, I'm going to keep moving. Okay, Ms. Sumati, please say a few words, and then finally Zulfi. Please don't hesitate. Don't be shy. This is your place, our place of learning and being great friends here in the data science world. Okay. All right. I keep moving. Okay, that's fine. Thank you very much, Krishna, for joining. Finally you could connect. That's wonderful. So here is another example I want to show you. We will do some examples a little later, actual codes and so on. Here is a series, and this series is eventually what you do is these are the values, you do forecast, and you build up confidence intervals also. Okay, that's what we want to do. This one we don't have a confidence there. That's usually you need a confidence interval also. So this is an example I wanted to touch base on how you can do the smoothing. Okay, smoothing is the first principle in forecasting. Okay, that means it eliminates randomness in the data. Very simple. Okay, there are many types of smoothing here. I'm not going to go into the detail here because I want to go into one final model, which is the ARIMA model. where your PDQ has to be estimated, right? We'll have to figure out what is the right P, the order of the autoregression. Q is the order of the moving average part of it, and then the D is the differencing part of it. So once you fix that one, how do we do the model? That's, I just want to give you one flavor of that before I close it, because I have one session to give you the 30,000, 20,000, 10,000, and yet, on the ground case study. Okay, so please bear with me. There is a lot of things to do. So, but you can see that, given a series, this is indexed as a indices, not as a time, but it can be time. Given a series, you can, and there is some, gaps here. Okay, there's a gaps here. We want to estimate it, basically use the smoothing method that will estimate the answer correctly. Okay, that's our goal. And there is a linear model you can build. That is the current values of, as a function of the previous value, one time period, for example. Spline, there is another method that we can use that locally, estimates the values, local averaging method. And then this is just a prior value. Okay, that's not the best. The next value, these are all not the best one, but people do all kinds of things, right? And then there is a smoothing method, weighted moving, simple moving average. Sometimes they call it a single moving average. Okay, you have to remember this, simple versus single for some reason, right? And there is also weighted moving average and then exponential moving average. Okay, these are all smoothing methods. Okay, this moving average is different from the, please note down this one, this moving average is different from the ARIMA moving average model that we are going to do. Okay, so when you do this, then according to this, in this series, which one comes out to be very close, very easy, because the validation is here, the values are here. So it's just a very simple calculation, but you have to think in these things. That's why I give you this as possible answer. So I remember I told you that once you have a series, you want to decompose it, and then you find out what is the seasonal part of it, trend part of it, residual part of it, or cyclical part of it. Okay. Trend, usually trend and cycles, both three things are there, right? Original series with respect to seasonal, trend, cycles, and then the residuals. But here it is about irregular or cyclical component only. But you also sometimes the softwares will print for the errors also. After subtracting or removing these things, what is remaining? That is the that is the residual part of it. And you can see this. This is the original series. Okay. Could you have thought about that? It is such a perfect seasonal component is hidden there. Isn't it beautiful here? I'm kind of fascinated that the mathematics pulls out the seasonality. It looks like that, but still, because of the trend, the cycles and some errors here, you can't really say there is something going on, but you can't say such a perfect seasonality is going on. But the mathematics will help you to do that one. Okay, that's one point. Then it is not just that alone, right? That seasonality means, it is simple, pure seasonality means it doesn't have trend, right? And that's where the trend component is, pulled out here. There are many approaches to time series. Decomposition, 1 second, please. It disappeared. Thank you very much, Ahish. I mean, your questions are great. I appreciate it. There are many approaches to time series. Yes, you are right. Decomposition, STL, absolutely you are right. In fact, if I have to tell you, go for X11, which is, you didn't mention that X11, is a special census, Department of Census has, developed, popularized, uses it heavily and popularized. And I have used that for, I'm talking about 15 years back, I used it for insurance. The rest of them are, the end values can be problematic. Okay, most of the things, okay? End values can become problematic. X11 ARIMA, I'm saying you build ARIMA and then you use X11 ARIMA, okay? X11 smoothing. That is, I would say, is the best because it takes care of a lot of little things, including the outliers and the end points of the series. End points of the series are well handled by X11 ARIMA. I hope you didn't expect that answer, okay? Okay, all right. Great question. Thank you very much, Ayush. Trend component, you want to separate out all those things so you can articulate what's going on in the series, right? You can explain this seasonality, accordingly you can predict certain things and tell them, hey, you know what, you have to put the campaign just around this time so that you know that it's going to be having a great effect. Or maybe if you want to reach the bottom part of this series because that has a positive impact on your ROI, then you should say, you know what, our campaign should be happening somewhere here, so that so that you are able to articulate only because you decompose this series. In the same way here, for some reason the trend was going up, and then and then it's kind of tapered out and went down, and then it picked up again, it's going up, and it is not cycle, it is just a trend. Remember that. Okay, cycles are the long irregular cycles are here, it's going down, up, and then another 5, 10 years, 5, 7 years, it's going down, going up and down, and so on. Okay, so is decomposition important, you guys think? What do you think? Just give me an input. I love to hear ask this kind of question. How many of you think that decomposition will help you in your job? Go ahead, please. I'm curious to hear. What do you think? Interaction is very, very important. I want to know, at least a couple of people should answer that question. Jeremy left. Okay. Go ahead. Is the question clear to you? In your job, do you feel that decomposing a series of observation, it could be training you give to people, or your sales activities, or your financial series, that you have to handle, is decomposing the original series into seasonal, trend, cyclical, and residual. Do you see how you can use it in your work? I mentioned, in a sales campaign, campaigns can be, addressed according to the seasonal cycle, for example, right? But in your work, somebody, at least one person, I'm hoping will interact with me. Oh my goodness. All right. Okay. You can type.
Use it
Okay.
to cluster similar time series. So when you are having, say, you're having a large basket of products which you are selling, and you want to identify those products which are having a similar sort of a sales trajectory. So decomposing
good
a
idea.
time series, comparing the different decomposition parts can help you cluster.
Yeah. Great. My goodness, you solved a very important problem. That is, you have multiple products, many products, and then you are saying, you want to cluster products in terms of the seasonality components, trend components, so that you can act differently according to the cluster. Amazing project, man. This is something you should propose. Probably you are doing it regularly on a daily basis. Very good idea. Thanks a lot. Who is that one? I really like that. Very insightful comment. May I know who answered that? You can type if you don't want to talk. Okay, whoever said that, that's a phenomenal, great answer. Somebody said in marketing, Gaushali, of course. Yeah, of course, marketing. We talked, that is a marketing example also. Brian was asking, is differencing part of the decomposition? Differencing helps you to figure out all these things, because you have to difference first before you do the decomposition. Okay, so differencing removes the trend so that you can do the ARIMA model. Okay, here is the thing. Let me explain it better this way. Differencing is used to do the ARIMA model, which is the auto regression, the modeling of regression type modeling of your series. Either because it depends on the actual values depend on the previous values, or the errors depend on the previous values. That is what the ARIMA is. Okay, this one what I'm talking about is decomposing the seasonal component, trend component, and the cyclical component, which you are going to do the differencing here, so that in this case, okay, for example, the original series is the differencing here, so that you are removing this trend, right, and the seasonality also. Then you do the ARIMA model. Is that clear to you, Brian? Your ARIMA model builds the for prediction after you remove the seasonal component and the trend component through the differencing. Okay, I hope it's clear. Great. Okay. Thank you very much. That's wonderful. So now let me show you a few examples. So here is actually a data USA accidental death, US accidental death from 1960 onwards, and we can do that. Let's just go. This is available. The data set is available. So in what is called the data set. Let me do that. I'm trying to get out of this screen. Okay. So that I can actually run this. Nowadays software is developed so well. It is more important to think why you want to do what you want to do, because the how part of it is very, very straightforward, very easy. Just a couple of lines, it will solve you the problem. As long as the data set is properly defined as a time series data, use this command like this. For example, you will get this detrending. I just want to talk about this example also. Okay, so let me do this one because I have done the already the data sets and all these things. Let's just run this one. The T-backs, right? So it's a part of the forecast package. So run this one. Or something happened. I should remove those greater than simple. Okay. All right. Now let's do this. There you go. Okay. So simple, so straightforward, right? So easy. Let's zoom it and see this one. See again, for the data, the observed data is this one. It looks like there is something is going on in terms of seasonality, but can you feel that there is a trend is also going there? You can't visually, right? That's where the mathematics helps you, computation helps you. And there are different ways to represent, this is one of the ways of representing, slope, season, and level. Level is the, local movement of the trend. Slope is, a little bit more, longer trend. Can you see that? I can see that now it is going down because the peak is going down and the bottom is going up, right? Peak is going down and bottom is, of course, looks like going up, but nonetheless, the middle points are going down. Do you see this one? There is something going down and then going up. That's exactly what this is picking up. But that's because I was looking at it, like this, for 5 minutes, and then I realized, yeah, there seems to be something wrong. Okay, let's do this analysis and see what happens. And then it did show that one. Okay, this is the slope. This is a lot more relevant to the. I might have said this. This is a little bit longer. Leveling is longer level. Compared to this one. This is a local slopes. Okay, these are the local slopes. And then it is also giving a seasonality. Beautiful. Look at this one. This probably, you see it is hidden, but the mathematics and computation helps you to see, bring it out very clearly. Seasonality is beautifully pulled out here. Okay. So let's do one more example. I really want to give you a ARIMA quick review, how to determine PGQ. Okay. Not this one. Let me go back to this. Stationarity, right? Here is a couple of examples of, which of the series are stationary here, because stationarity, if it is already stationary, you don't have to do the, different thing, right? But this is the trend. If you remember, what I said is that there is a pattern there. It is not stationary, period. That's it. Okay. So you have to differentiate to get the stationarity. So here it's a Google price change, but then once you do the different thing, this is what you get here. Different thing. Okay, 200 days consecutive Google price, but the different thing has an exceptional. You cannot use this point and then still model it correctly. Okay, the ARIMA model of this one. So you have to remove this one, or winnow it. Winnow it means bring it down to based on the averages. So here you see here, bring it down to that one. Then you do the ARIMA model there. Okay, this is again is not stationary. None of them is stationary here. Okay, this looks like somewhat stationary. There is cycle. This is a seasonality is here. Of course, this is not stationary. Okay, this looks like somewhat stationary. Okay, but that seems to be probably. Oh, you know why this is? Okay, let me make it bigger. You see this one? seasonality is, remember, it's a short cycles, right? Compared to big cycles. This is a bigger cycle. That's why, it's considered, bigger cycles are accepted to be okay as part of the stationary. Okay. That's what, that's what I see. It's somewhat unusual statement, but that's something you have to keep it in mind. So this is stationary. After doing the first differencing of this one, these are all not stationary. You can do differencing and find out. But the notes here says that this is also stationary. So in summary, logarithms can help you to stabilize the variance. Differencing can help to stabilize the mean of the time series by removing the changes in the level of a time series, and and thereby eliminating trend and seasonality. Now you can do the ARIMA model. Okay, so let us do quickly an ARIMA model. So for ARIMA model, you have to look at the autocorrelation function and partial autocorrelation function. If you look at the autocorrelation function here, it's high numbers of correlations are there and they are systematically going down. Okay, and this one is after the difference. This is the Google data. After the difference, there is one big number here. Okay, one lag. This is the ACF after one differencing. Okay, ACF one differencing gives you one huge number. That's it. Everything else is within the bounds. Okay, so this sample autocorrelation perfectly tells you that the first differencing will help you solve the problem with the AR1. That's the AR1. Okay, and that's what you see here in terms of the let me make it bigger. That's what you are seeing it. This is a different series. This is a different series. So not the Google data. This is a different series. Here you are getting this, after the time series plot of mortality differences. So this again is a difference data. Okay, difference data. It looks pretty good. So once you take the difference, then you are out of, you have a correlation of negative correlation, and then everything else is, order one, negative correlation. Everything else is 0. So again, this is a AR1 model, but more complex models, you can build. So there is some mathematics here, and then there's a code here. What I want to show you is, I encourage you to, let me explain this one in a couple of minutes. So the ARIMA model, the mathematics part is that if you don't have, this is the lagged variable, right? So X is your time series value, just one series, right? But that series is modeled as mean, okay, centered, and then you have xt minus 1, xt minus 2, and then p time periods. It depends on p time periods, the x values, the series values. On top of it, we are saying the error after this is removed, still there is error there. That error can be modeled, the error values can be modeled as the previous errors and so on. So there is a regression part of errors, there is a regression part of the series values itself. That is what your PQ is. Determining order PQ is the problem to solve, and once that is solved, you can build the model. Okay, we talked about the differencing parameter D. So if we say the identification model is done when we identify the values PDQ, once that is done, we can estimate the model using typically a loss function, that is least squares. Least squares is the loss function that we will use. Now, we talked about this. I encourage you to go through this example and that example. That's a case study I wanted to spend time. Okay, I got 1 minute. But in detail, he talks about what is the model we have to use, because there is a D differencing is there. ARIMA 010 is there, but then he keeps building it. Okay, saying that using the ACF and the autocorrelation function and the partial autocorrelation function, you can determine it's coming out to be second order AR, and then D is 1. There is no moving average part of it. That's the model you identify it and you build it. It gives you the answer in the analysis, whatever you do. The codes will give you that model. Look at this one. You ask for that model, this kind of model, it will give you the answer, and it tells you with the various metrics. It determines, which is the, how good that model is. Okay, that is how you build your time series model. So in quickly, what I did so far is basically I went through all these various methods. In summary, this is what I was talking to you. I liked this. I took a lot of time to create this slide. Okay, this slide. What do you do when you see a time series data, right? This is what you do. This is what you do. That is, you visualize, you identify the repetitive patterns, you do the smoothing, you figure out cycles, trends, repetitive seasonality, and then separate out the components. And then when needed, you do the ARIMA or SARIMA algorithms. Thank you very much, everybody. If you have any questions, it's the best time. We have a short time, so go ahead, please. I appreciate all of your patience. Everybody's sitting even after 10. Go ahead. Any questions? Take it over, Gaushali. Thanks a lot. We do diploma in our data science program. So if you come, we spend a lot of time as lab hours with you. Make sure that you do all these things, not just we do. Okay, so it's a 6-month program, and we are very happy to provide a very inexpensive training. I do this because I spend a lot of, I come from where I was born and so on, from India. So for those students' sake, I have made it very, very inexpensive, these courses. So if you want, you can join. By the way, we are hiring 4 people in the next 3 months, I would say. Okay, 4 people we need, for our project. So definitely, those who do very well in our program, in our course, will be hired into our program and into our jobs that are coming up in the next 3 months. Okay, Vasu is there. Are you there, Vasu? I kind of talked about it also. Want to contact for data science? Oh, just send it to me. My name is Netra Sambamurthy Rahul. Netra NSM at 0 NS. Let me put it here. NSM 001 at gmail.com or Gaushali. One second, I will write it. NSM at Institute of Analytics. Let me put this. NSM at Institute of Analytics. Or you can do another one is Gaushali at instituteofanalytics.com. Please reach out to either one of us.
Dr. Netra, I'm there.
And I certainly encourage you to do the data science diploma or some program, because these are the best times. So here is the phone number also for you. These are the best times. So any questions? Any other questions?
Dr. Netra, you asked me whether I'm available. I'm Vasu here.
Yeah, I saw
you wanted
that. Okay, you can close it, Vasu, today. How about that?
Oh yeah. Thank you all for your valuable time being spent here. I'm sure that you would have had a lot of takeaways from the session that you have attended now. And we don't stop here. We keep doing it every week. And it's a series that is being offered by the Institute of Analytics. And Dr. Netra, he himself takes the lead in offering this program week after week. So I'm sure those who have been attending regularly and those who have been joined today for the first time will see that there is a lot of value addition that will be happening. And so we look forward to see you all again next week, same day, same time. So till then, have a nice time. Wish you all the best. Thank you.
Thank you very much, everybody. Have a great rest of the day, whether it's evening or the whole day. I am here in USA, whole day is opening up for me. Thank you very much. Bye-bye.
Bye.
I will post this recording in the YouTube as well as in the meetup sessions, okay, wherever you join from. Bye. Thank you, Mr. Venkata.
Thank you, sir.
Subbareddy. Thank you. Thank you, Gaushali.
Thank you. Thank you.
Thank you. Thank you, Supriya, Agish, Brian, Nazri, Miss Sudha, Miss Sumati, Miss Supriya, Mr. Venkatesh, and also Mr. Webinar registrant as well as Mr. Zulfi. Bye-bye.